So guided practice 4.3 has an objective to determine if lines are parallel. So let's review what we've learned, or at least the essence of what we've learned so far. We've learned that if two lines are parallel, then corresponding angles are equal in measure, alternate interior angles are equal in measure, and same-side interior angles are supplementary. But what we're going to learn in this lesson is that the converse of these statements is also true. In other words, it is also true that given two lines and a transversal, if the corresponding angles are equal, or the alternate interior angles are equal, or same-side interior angles are supplementary, then the two lines are parallel. Okay, so we've got ourselves a biconditional statement. And we can say, for example, in a biconditional statement that corresponding angles are equal if and only if the two lines are parallel. We can say that alternate interior angles are equal if and only if the two lines are parallel, and same-side interior angles are supplementary if and only if the two lines are parallel. So one way to go about proving two lines parallel is to prove that either corresponding angles are equal, alternate interior angles are equal, or same-side interior angles are supplementary. If you prove any of these three things, you can conclude that the two lines that are cut by the transversal are parallel. Let's see some examples of that remarkable fact. Okay, let's look at A. We have a diagram where we have lines H and G, and we don't know much about these lines H and G other than that they intersect this line, we'll call it L. But now we're being told that the measure of angle 1 equals the measure of angle 2, so that these two angles are congruent. Well, we know from what we've learned so far that these are corresponding angles. And what this statement says then is that these corresponding angles are equal. Well, if we go back and we take a look at what we know that given two lines and a transversal, if corresponding angles are equal, then the two lines are parallel. So we can conclude that line H is parallel to line G. And the reason for this is that corresponding angles are congruent. They have the same measure. They have equal measure. And the statement in general would be that if corresponding angles are congruent or have equal measure, then the two lines are parallel. Good, let's go on to the next one, statement B, problem B here. Again, we have two other lines, line M and line N. And let's say that this transversal is line P. In this case, we're given the fact that angle 3, or the measure of angle 3, is equal to the measure of angle 4. That these two angles are congruent. What can we conclude about lines M and N? Well, these lines are on opposite sides of the transversal P, right? So they're alternate angles, and they're between M and N, so that makes them alternate interior angles. And we're saying that the measure of these alternate interior angles is equal, or that the alternate interior angles are congruent. Well, we said here that if alternate interior angles are equal measure, then the two lines are parallel. So we can conclude that M is parallel to N because alternate interior angles are congruent. And the statement in general would be if alternate interior angles are congruent, then the two lines are parallel. And let's go up to C. We have another situation here. We have lines A and B, which are also cut by a transversal. Let's call this transversal C. We are given that angle 5 supplements angle 6, that these two angles are supplementary. Well, what can we conclude about lines A and B? Well, let's go back to our statements here. And we may remember that if, given two lines in a transversal, if same side interior angles are supplementary, then the two lines are parallel. So, in this case, because 5 supplements 6, we can conclude that A is parallel to B because same side interior angles are supplementary. And the general statement of this fact is, if same side interior angles are supplementary, then the two lines are parallel.